The top speed of the coyote is 43, and that is greater than or equal to 3 times the squirrel's top speed plus 7. So it's not just 3 times greater, it's 3 times greater plus 7. So a lot greater than the squirrel. Okay, this is called the two-step inequality, and this is a review of equations, okay? But what's the difference between equations and inequalities? Yes, the inequality is simple. You guys are doing great today. How many of you are tired? Cold? Cold and tired. Okay. Yeah, usually the things that kind of hinder us, but let's try to make it through here. What's happening to S first? First it's being multiplied, then it's being... So what do I undo first? What do I undo first? Yes, ma'am?
You subtract the 7 on both sides.
Good. Subtract 7 from both sides, and we get 36 is greater than or equal to 3s. Then what do we do to both sides? Yep, Drew. Divide both sides by 3, and I get 12 is greater than or equal to s. And how do I write that to maybe make it easier to graph if I wanted to? S is less than or equal to 12. What is that telling me? The top speed of the squirrel is less than or equal to 12. So what that's saying, by the way, when we say top speed, do all squirrels go up to 12 miles per hour? No? Can they? Is there a squirrel that maybe only goes up to 11 miles per hour? 10 miles per hour? Any that go 13 miles per hour according to this problem? No. So that's the top speed. That's as fast as they can go. Do you guys remember how to graph it? What kind of circle goes on 12? Closed, because it can be 12 or anything less than. So that's why we're going to draw this arrow. It could be anything below that, but it can't be anything above 12. It could be 12 or anything below. On your quiz, like I said, your scores were very high, and that's a good thing. But if you missed some points, you know what it was? It's sad, but it happened. You had the right inequality, but you didn't put the arrow going to the left. You put it going to the right. Now you're like, well, how do you know which one's right or wrong? What could you have done? Check it. So can anyone tell me what number should work in this inequality? 11. Okay, 11, right? I'm going to look back at the original. What's 3 times 11? 33 plus 7. 40. Is 43 greater than or equal to 40? Yes. So doesn't 11 work? Yes, it does. What about 13? Should it work? What's 3 times 13? 39 plus 7? 46. Is 43 greater than or equal to 46? No, that's why I didn't graph it. You could have checked every one of your answers and told me this was right, this was wrong. Some of you did do that. I was like, whoa, they checked every one. And some of you didn't check, and you maybe missed more than you should have. So just be careful with that. All right, let's go to the next problem. And actually, the way the problem's given is like this. And notice I just erased a 1, but was that necessary? I don't know. It just depends, I guess. Okay, it was. And it's going to help you out with this problem. Now, on these problems, just like yesterday or last night's homework, you want to make sure both sides are simplified before you start doing anything. How many terms are on the left? 1, 2, 3. Are there any like terms? Like terms. Which ones? And negative 3c. So what's the number in front of c? 1. What's 1 minus 3? 1 minus 3. Negative 2c minus 4 less than or equal to negative 2. Okay, great. What's happening to c first? First it's being multiplied. Then it's being subtracted. What do I do first then to undo this? Add 4 to both sides. And be very careful with your signs because that does throw you off. What's negative 2 plus 4? Yes, 2. And I forgot that symbol. 2. What do you do to both sides here now? Okay, I divide by negative 2. What do I get here on the left? C. What do I get on the right? Negative 1. And what's my symbol?
Greater than or less.
Greater than or equal to. Why is it greater than or equal to? Ooh.
Because when you divide
Okay, close. There's one little thing you want to say. If you multiply or divide both sides by a negative. Did I multiply or divide both sides by a negative? Yes, I did. So I have to switch that up. What kind of circle goes on -1? Close. Where does the line go? To the right. But is that really true? Because if I switched this and it wasn't supposed to be switched, won't that graph tell me? Won't it tell me if it's right or wrong? Matthew, pick a number that is correct according to my graph. All right, 0 right here should be an answer. What's 1 times 0? 0. What's -3 times 0? And we're adding or subtracting, doesn't matter. -4. What's 0 plus 0 minus 4? Is -4 less than or equal to -2? Yes, so that's why 0 works. Jack, give me a number that doesn't work.
-2.
All right, -2 shouldn't work, right? So, what is 1 times -2? -2. What's -3 times -2? +6 minus 4. All right, ready? What's -2 plus 6? 4 minus 4? Is 0 less than or equal to -2? Is 0 less than or equal to -2? No, it's not. It seems like it is, but it's not. 0 is not less than or equal to -2. That doesn't check. So do you see how my graph shows that? You can know it. Yes, sir.
Are we ever going to have to graph, like, is not equal to?
Wait, that weird symbol? Yes. Just not today. Wait. No, not today. Yeah, and really, let me just give you a sample problem. All right. I want you to pick any number except 10. What are your options? 9, 11, 9.5, 10.2. Okay, what numbers can I pick? And you're like, it's an infinite number, but how do you graph that? It'd be simply, so this is x does not equal 10. So the way I'd graph it, start with 10, go 11. That look familiar? Okay, what kind of circle do you think would go on 10? Open circle, line going to the right and to the left. Because it's everything except for 10, right?
And it would, if x did equal 10, it would be just shaded circle.
Oh, see, and that's a cool, okay, let's say, what about x equals 10, right? So, here, I'm going to do, and you could graph this, you don't have to, but you can. This one's a little bit simpler. What kind of circle goes on 10? Closed. And no arrows, because it can only be equal to 10. So you see how when you say it's not equal to 10, it's anything but 10? But if you say it's equal to 10, guess what that means? It's equal to 10. That's it. That's all you're... This is chapter... No, not chapter 4. No. Should it be? Well, now that I think about it, you guys are ready for that. What do you think, Michelle? Oh, wow. Okay, great. Thank you. It's okay. We will see that. We will see that in the future. Good question. Okay, let's do another problem after we graph this one. Nope. What kind of circle goes on -1? Let's move on. Okay, let's do this one right here. Ooh, sorry. Did you guys notice how this class flows? Have you been realizing we kind of do a real simple problem to start with? Then we do like maybe a simple problem to a little bit difficult, more difficult, and then what happens? I just throw you a hard one. Here, do it. But you're using the same principles, guys, so we're going to look through it the same way we did the other two. All right. On this problem, are both sides simplified? No. Look at the left side. Is the left side simplified?
No.
It doesn't look like it, but it is. Yeah, that's as simple as you get. What about the right side? No. What's 7 minus 3? 4. Oh, okay, I can do that. Now, I need to take a little pause here and write something on my board with that problem, because I want to help some of you out who maybe don't see it the way we're going to look at it right now. Okay. How many of you are very uncomfortable with the e over 5? In fact, you thought that could be simplified. How many of you were like, I don't like that. That's weird. Thank you for being honest. Some of you don't like it, but you don't want to admit it. So let's deal with it. E over 5. Okay? This can be rewritten in a way that's maybe easier for you to look at and even to deal with. I can write it as 1e over 5. Do you guys remember there's a 1 there? Some of you aren't even looking, so you don't know what I'm talking about. All right, do you know that there's a 1 there? Okay, and then you're like, that didn't help me out. But what about if I break this apart and say 1/5 e? Am I allowed to do that? Do you guys remember this? Okay, you can do it like that. I'm not going to work it out this way in this problem, but you could if you're really like, oh man, I hate that. Fine, deal with it. Switch it up a little bit differently. So I'll leave that up there for you at future reference because you will see this very soon. Very soon, as in very soon. Yeah, but sooner than that. What's happening to E? First it's being divided by 5, then added with 8. What do you have to undo first? Undo the addition by subtracting 8 from both sides. Oh, you subtracted from both sides. What happens to the inequality?
The same.
Stays the same. Good. Trick question. What's 4 minus 8? Good, -4. Good job, guys. What do you do to both sides here to get E all by itself?
Multiply.
Yes, ma'am?
Multiply by 5.
Multiply both sides by 5. And you're left with E. And -20. And what symbol? Greater than. It did not switch. It didn't switch at all. -20. What number goes on the right? -19. Does it? Does that? On your graphs on the quiz, I was actually proud and impressed. A lot of you did do this, but some of you are switching these up. You put -19 here and -21. If you do that, what happens? Well, not only is it wrong, but why? Because everything got switched around, so it's actually opposite order, so be careful with that. But just be careful, least to greatest. What kind of circle goes on -20? Open. Line going to the right. That is correct. Okay. What number would I want to check? Because not all numbers are nice to check. So look at my number line and look at my original. I'm like, do I really want to pick -19 to check?
Well, negative.
Why -15, Drew? You said it too. Yeah, -15 is a multiple of 5. What's -15 divided by 5? What's -3 plus 8? Is 5 greater than 4? So that checks, right, that -15. And what number would I want to check on the left?
-25.
You could do -25. Good. What's -25 divided by 5? -5 plus 8. Is 3 greater than 4? No, that's why I didn't graph it. Do you guys see how you can check these? And again, to make your life easier, you could do -21, can't you? But what's going to happen up there? You're just going to get a mixed number or an improper fraction, which you can't deal with. You should be able to deal with, but checking makes it easier. All right, I wish they were all this easy, but they're not.
It's hard.
What? You stole my line. Look at it. It's actually not that bad, thankfully. Thankfully.
As long as you don't get it.
Yeah, just kind of like take a breath and like write it down.
As long as you don't mess up.
Write all the signs correctly, the numbers correctly. Write it neatly. Don't rush. Then take it. All right, are both sides simplified? Are they as simple as can be? No. The right side, oh, it's very nice. But the left side is not. How many terms on the left? 1, 2, 3. Are there any light terms on the left? Brad, which ones?
2/3 and -1.
Okay, so we're combining these two. What's 2/3 minus 1? -1/3. How'd you get that? Like how? Like, because I don't get it. I'm confused now.
1/3 plus 2/3 equals 4.
Yeah, I think you got it, but now that I want the explanation, that might be tough. Yep. See? What do you think? Help me out. I'm confused.
Because you did. Never mind.
Okay, I'm so confused. Yes.
It'd be the same as 1 would be 3 over 3.
There we go. That's. I need an explanation here. Isn't 1 also known as 3 over 3? What's 2/3 minus 3/3? Negative 1/3. Okay, so I got negative 1/3 m plus 2 is greater than negative 1. Hagen, what do I do to solve this problem? What do I do first?
You subtract 2 from both sides.
Right, subtract 2 from both sides. I get negative 1/3 m greater than negative 3. Hudson, what can I do with that negative 1/3 to get rid of it?
You can do negative 3 over 1.
So what do I do with that? I multiply. I multiply this by negative 3 over 1. What I do to one side, I got to do to the other. And you're like, wait, what? What's negative 3 over 1 times negative 1 over 3? 1. Good. 1. And what's 1 times m? M. Okay, and then what's negative 3 over 1 times negative 3 over 1? Positive 9. You're right. Positive 9. What? Why?
Because if you multiply negative or divide it by negative to
Both sides. Switches it up, so it should be less than. So how do you graph m is less than 9? 9, 10, 8. What kind of circle on 9, Mary?
open.
Open. Line going where? Andrew? To the left. Okay, so that's it. Yes, sir?
How'd you get 3/3?
3/3. Oh, right here? Yeah, 1. So we had 1, right? Isn't that 1 over 1? Okay. But can you do 2/3 minus 1 over 1? Or don't you have to have common? So what's the common denominator?
3, so you have to multiply 1 by
3 over 3. Yep. So you get 3/3. Good question. You're welcome. Yeah, what is this? Oh, sorry. This is just number 2. Sorry. That's number 2 on page 109. That's what we're doing. These aren't too bad. How many of you don't feel too intimidated by this? You know why you don't feel too intimidated by this? Because you already saw these problems in chapter 3. These were in chapter 3, and you're like, whoa, what am I doing here? Now you get them again, and it's like, come on, Mr. A. Guess what? You're going to get them again. And when you get them again, you're going to be like, Mr. A, do you even have to talk through this? Yes, and thank you, and I'll say you're welcome. Okay, good. Go ahead and try that out on your own as best you can and get a graph. And if you have time, check it to see if it really works or not. And there are multiple ways to go through these. Just looking at it, there's several ways, but help yourself out by going through our process. Trust the process. All right, I'm going to help those who are kind of stuck. You're kind of like, I don't know what I'm doing. How many terms on the left? Terms on the left. 1, 2, 3. Any like terms? What's 7 plus negative 9? So I got negative 2 plus p over negative 3 greater than or equal to negative 5. What do I do first? Add 2 to both sides. Good. And that gets rid of this. You got p over negative 3 greater than or equal to negative 3. Then what do you do to finish this off? Yep.
multiply 3 by both sides.
Not just 3, but negative 3. And why am I emphasizing the negative? Because something happens when I multiply both sides by a negative. What was that? Sign switches. Is that important? Yes.
Very important.
So P is less than or equal to 9. Whoa, that looks familiar. What kind of circle goes on 9? Line going to the? There you go. What number would you pick to check? Alex, what number would you pick to check?
9.
Okay, 9 you could pick. So should 9 work? It should work. I really hope it works. What's 9 divided by negative 3? Yeah, 9 divided by negative 3 is negative 3. What's 7 plus negative 3? 4. What's 4 minus 9? Is negative... Oh, I'm so sorry. Is negative 5 greater than or equal to negative 5? Yes, so it does work. What number would you check to make sure didn't work? What's a number that should not work? You know it shouldn't work because you picked it. Yep. 12. So something over here. What's 12 divided by negative 3? Negative 4. What's 7 plus negative 4? 3. Is 3 minus 9? Is negative 6... Ooh. Negative 6 greater than or equal to negative 5? Oh, that's a good thing, isn't it? Because I didn't graph it. You guys get that? Okay, you know what? Today, this year, we're emphasizing a two-dimensional graph. This is one-dimensional technically. One-dimensional graph. Guess what we're doing next year?
3.
No, 2. Don't get ahead of yourself. Two-dimensional graph. And that is what 8th graders are doing today, right now. They're doing it not just with one number line, but 2 number lines. Can you use inequalities with that? Of course you can. Will you use inequalities next year for a... Of course. Wait. Yeah, I'm not going to... Oh, you will do it. Okay. Yeah, you will. Okay. Is it that time already? I will find it.
We do the same number of practice problems every single day.
Every single day? Every single day.
Well, actually, I'll do the next 5 on 12.
You're doing an analysis of my practice, which is cool. Thank you. All right, goodbye, Swivel.